Okay, moving forward, I want to show a set of analysis results just as an example. And sorry. So this was looking at the impact of different types of utility rates. And so the CPUC Energy Division recently did some evaluation. We have here for PG&E and Southern California Edison some typical rates during 2013, and then some illustrative other types of rates. So a time of use rate, and rather than a 4-tier rate, a collapsed sort of 2-tier rate. And so there's values specified here describing those, and we have developed custom or user-defined rates in BEopt using the utility rate wizard to account for these kind of values, and then explored some analysis results over a couple different locations. Sacramento, Riverside is kind of east of LA in the Southern California Edison service territory. 2 different climate zones, and some different building characteristics, a large house, a small house, and we also had the small house using a lower level of miscellaneous electrical use, so to get some different cases. So what I'm going to show first is not the full range of these possibilities, but just Sacramento high use cases. And so here are participant cost test results for 4 different tiers. So this is sort of the typical current tier for or rate for PG&E. Again, Sacramento high use, and this is the participant cost test value. The first part of this is efficiency, which improves from the participant's point of view. The net present value is beneficial. And from this point on, then the building designs are incorporating increasing amounts of solar in 1 kilowatt increments. And there's a knee in the curve up here. It actually occurs a little bit before 100% TDV savings. But this is really when 100% electric, when we reach 100%, and we have to start having annual excess in the net energy metering situation, which is valued less than what's happening up here. Here's a 2-tier rate, which is kind of a flatter rate. You see a little bit of dip here. This, again, is because we have this nonlinear PV cost that has economies of scale. So this first dip is relatively expensive, 1 kilowatt PV system, and the PV gets somewhat cheaper. And then this is the time of use rate. So it's interesting to see that depending on the rate, there's some different valuation. Again, this is the participant cost test, so this is to the homeowner in terms of the efficiency is somewhat similar, but the response to PV is somewhat different in the evaluation. These are, I should back up and mention this sort of caveat that says really that these are just example results, and in fact they're sensitive to a number of assumptions and could change significantly over a range of plausible inputs. So this is really, the purpose of showing these is just to illustrate the new capabilities in BEopt for doing this sort of analysis, not so much relating meaning to these specific results, but to see what the form is. So if I take the optimal curves from these 3 plots, discard the gray points, the non-optimal designs, and just take the boundaries, the curves, and overlay them. That's the first plot here. Again, it's kind of just showing that shape, the same shape that we saw in those plots, as a function of different utility rates and how the net present value trends as we go from the reference building towards the zero energy building. If we look at the total resource cost test, if we recall, there was actually the utility bill savings aren't really a component of the total resource cost test, so the curves pretty much are on top of each other. Small differences, probably reflecting the fact that there are, in fact, slightly different building designs found in the optimization for the three different rates here that change the avoided cost slightly, which is a component of the total resource cost test. But pretty much the trend is similar. For the rate impact test, ratepayer impact test, you may recall that the bill savings actually are a cost to the overall rate impact ratepayers, and so they do factor in, and there are differences. In fact, the curves here are somewhat the inverse of the participant cost test. So again, some different trends as a function of different types of utility rates. So I have a few more plots where we bring in the Southern California cases and also bring in the Riverside and bring in the low energy use. So now we have more parametrics and the resulting curves. And so this is sort of like the first set of plots that we saw, again, looking just at the optimal curves, not the gray points. And what we have here is the top curve is PG&E or Sacramento, which is has a more extreme climate than Riverside, and this is the high use case, large house, and then Riverside, high use case, and then Sacramento, small house, low use, Riverside, small house, low use. And so we just see that, you know, the shapes are similar, but things change a bit as you change location and house characteristics. If we look at all electric houses, in this case, there's electric heating, and so there's a change in scale. Actually, here the maximum was 18,000. Here we're up to 26,000, and then on this particular scale, the uses are very much higher with a maximum 45,000. So, and there's actually a change in shape trend here compared to here, and this is probably because there's this very high electrical use puts a preponderance of the consumption into high tier territory, and therefore, in this case, some of what was happening is we were moving from high tier into low tier, whereas here it's just kind of locked in at the high tier rates. So just a range of different results. Same sort of thing for a dozen different cases. The TRC, as we saw before, for a particular location and house type collapses, but there are 4 sets of curves as a function of location and house size. And the all-electric is somewhat similar, a little bit more variability within the groups. So that is the example of analysis.